All right, Chapter 9, Problem 33. We have a 3 kilo baseball just before and just after it collides with a bat. Just before, it has a velocity of magnitude 12 at an angle of 35 degrees. Just after, it's traveling directly upward, a velocity of 10. Duration of the collision is 2 milliseconds. So what are the magnitude and direction of the impulse on the ball from the bat? And what are the magnitude and direction of the average force on the ball from the bat? All right, so let me look at this picture again really quick. So the bat, okay. So we have y coordinates are up. Freehand. Here we go. Don't know how that happened. So the ball is coming in like this. That angle, theta 1, is right there. That's 35 degrees. Okay. So we got 35 degrees right there. All right. All right. See if I can draw it without invoking the magnification. 35 degrees. Okay. And so that means the x component is going to be minus 12, right, meters per second times cosine of 35 degrees. And the y component is going to be minus 12 times the sine of 35 degrees. And then afterwards, the momentum is all up, and it's 10. The velocity is 10 meters per second directly up. Okay, so let's start working. What is the initial momentum, right? P vec I. Okay, in the x direction, minus 12 meters per second times 0.30 kilograms times the cosine of 35 degrees, I hat, minus 12 times 0.300 kilograms, 0.300 kilograms times the sine 35.0 degrees, J hat. J hat. All right, so that's our initial momentum. And let's put that into, let's simplify this a bit and get the numbers from this. So we've got minus 12 times 0.3 times the cosine of radians of 35 degrees. And we've got minus 12 times 0.3 minus 12 times 0.3 times the sine radians of 35. So minus 2.95 kilograms meters per second, I hat, minus 2.06 kilograms meters per second, J hat. All right, that is our initial momentum. Now, what's our final momentum? Well, it's all vertical. So we got 10 meters per second times 0.300 kilograms times J hat. All right, so it's just going to be 10 is 3, right? 3.00 kilograms meters per second, J hat. J hat. All right. Okay, so that's our final momentum. So what's question A? What are the magnitude and direction of the impulse on the ball from the bat? Right? So part A, all right? Delta P vec is the impulse, right? The impulse is the change in momentum. And the impulse is just going to be P final minus P initial right? So 3.00 kilograms meters per second j hat minus, so this is going to end up being plus 2.95 kilograms meters per second I hat plus 2.06 kilograms meters per second j hat. Right? So the impulse ends up being 2.95 kilograms meters per second I hat plus 5.06 kilograms meters per second j hat. Okay, so what is the magnitude? Right? What is the magnitude? Which is what part A is asking for. So the magnitude is just going to be 2.95 squared plus 5.06 squared 1/2. Right? And that's going to be kilograms meters per second. So equals 2.95 squared plus 5.06 plus 5.06 squared. Take the square root of that. So 5.86 kilograms meters per second. All right, part B is the direction relative to the positive direction of the x-axis. Okay, so we have 5 up, and we have we have 3 basically horizontally and 5 up, and we want to know that angle relative to the positive direction. So we're just talking about the inverse tangent of the y component divided by the x component. So in part B, the angle we're at is just the inverse tangent of 5.06 divided by 2.95. Okay, so a tan of 5.06 divided by 2.95. Excel is going to give that to me in radians. Convert that to degrees. 59.7 or 59.8 degrees. Right? So that's the angle, 59.8 degrees. Okay. Now, part C and D are what are the magnitude and direction of the average force on the ball from the bat. So part C is the only interesting part here. So delta P is the force, right, times the time that this is applied for. The force is applied over. So the time is just 2 milliseconds. And since time is a scalar, the force is in line with the momentum change, right? The impulse. And so all we're really looking at doing is, what's our magnitude? Where's our magnitude? Is 5.86 kilograms meters per second. All right. So 5.86 divided by 0.002, since it's 2 milliseconds, and that's going to end up being newtons. 5.86 divided by 0.002, so 2930 newtons. All right. In part D, there's nothing about a dividing by a scalar that changes the direction, so theta is still at 59.8 degrees. All right, and that's it for Chapter 9 problems.